Hello and welcome to another short CMake video where we're going to be learning how to control the behavior of your program based on macro definitions that are going to be defined by CMake onto your program. For example, I quickly wrote this little program here that is essentially just showing the powers of pi, the integer powers of pi, and we can have two different behaviors here. So one of them is whether we're representing pi with a sort of double precision number here, so the double pi, or we're representing it with a floating point precision, which is less precise than double. And then the second behavior that we can control through CMake definitions is the maximum power to print to the user. In the way that I've written the program here, by default we're going to represent pi with float unless this macro double pi is defined, as you can see here. And also the maximum power of pi that we're going to display here is pi to the 10. And if you've used macros in C++ before, you know that I can by hand define double pi here, and this is immediately going to now compile this definition of the pi macro here, which is the double precision one, just as well as I could also define the max power here, and that is immediately gonna now display up to pi to the 20 here. However, the aim for this video is obviously not to define these things by hand and to pass it down through CMake. So maybe you've got users setting options or variables that will eventually be cascaded down to the C++, and these macros will be defined. So just as a little background here, the actual property that we're going to be using in CMake is the compile definitions here. So the compile definitions is basically just a variable containing all the macros that are going to be defined in your compilation. And as you can guess, this particular variable here, if you can set it yourself if you want, but it's not a per target variable. There is a per target variable definition in here called target compile definitions, which is very similar to other target functions such as target link libraries, kind of behaves in the same way. And this is the actual function you're going to be calling here. So let's take a look at the example just so we can quickly see how this works. So if I go into my main CMake lists, you can see here that I've defined an executable called program, which is the pi printing program that I've got. And I'm also linking it against the FMT library so I can do some nice printing. And this has been downloaded by Conan. So if you don't know what Conan is and you want to learn a package manager, feel free to check the video above here. It will be down here somewhere. But now let's actually call the target compile definitions here so you can see how it works. So let's do a target compile definitions. And the first argument to this function is obviously the target that you want to add those macros to. So in my case, it will be program, because I want it to be included in the program.cpp file here. So let's do that. The second argument is the access modifier. So in here you can have either private or interface or public, right? And just as a short description, it kind of behaves in the same way as object-oriented code. So public will mean that all these macros will be available to the target you're defining and all the targets that will sort of like inherit that target. So if it's a library, wherever you include that library, those targets that you're including your library in will also contain the macros defined here. So private is the complete opposite of that. So only this target contains this particular macros that you're defining here. And interface means that this target per se is not going to have it, but the targets that you include it in will have it. So if you're still unsure about this access modifier argument, I think they're actually called scope arguments. I will leave a link in the description to my article on the add library. And in there is a section where I describe how you'd use each one of these values. So, if you want to understand a little bit more, I'd recommend checking that article out. But for now, we're just going to put private here because we just want to make it available in this program. We don't really have any other targets. And finally, and of course, you actually have the macros you want to define. So in our case, if I were to define this double pi here through CMake, I'd simply just put that value in here. So that macro value, double pi. I'm going to save it. I'm going to, obviously I have to reconfigure my CMake. So let me do that. So delete cache and reconfigure. And if I go on to my program now, we should see this bit highlighting here, meaning that the double pi macro is now defined. And we're going to be compiling this version of the pi macro. So now let's do the same for the max power macro here, which is just controlling the number of times I'm going to sort of like raise pi or times pi by itself and basically get the power of pi. So currently it's 10, so let's change it to, I don't know, 20 or something like that, right? So let's do that. So in this case, you can see here that we're going to have max power equals 20 because you can do that as well. So not only can you set a macro to something, so not only can you set like a Boolean macro, which is either set or not set, you can also set a macro and pass a value to it. So max power equals 20. It's simply going to change the number of max power here to 20. So this is not going to compile essentially. because I already have a max power defined here. And this is what my macro logic here says. So let's compile this program and see what it kind of does now. So we finished compiling and let's take a look at this. So if I then call my program, I'm expecting, you know, powers of up to 20, which means that this max power is set to 20 now. I think my IntelliSense has been a little bit bad here by not actually showing which code is being compiled. And as you can also expect, the value of pi is being represented by a double, which means that my sort of variable that's tracking my power of pi is also a double here. And you can't really see this because it's to 5 decimal points, I believe here. Yeah, I printed it to 5 decimal points. But if we do a comparison between this code and the code without this double pi defined, you will be able to see a difference in the value. So let's just put it here so we can see. So double is going to be this. And if we change it and run this again, we have, as you can see, different values in this case here. So he loses the precision a little bit sooner, as you can probably tell here. So yeah, I mean, I hope this shows you how you can control the behavior of your program through CMake definitions here. So how is this useful? Well, as it is now, it's not very useful because, you know, as you can see, you still have to call this target compile definitions manually here. So you could have just put it as a definition here. You could have just defined pi as whatever you want. However, if you combined this target compile definitions with something like an option in CMake, so for example, I can have an option here called double pi or something, right? And this is going to dictate that we want to store pi with double precision. And the default value is going to be off, right? And we can also do one for the max power, as you can see here, and we're going to do it as 10. So now these macros can be controlled by the user themselves. And just to make things a little bit prettier, let's add a message saying that we're actually setting those values. So message, we pass in as a status here. And then we have something that's a little bit more configurable, so your users can actually set these values using the CMake configure argument. So in my case, I'm using a CMake presets here, so this is where I would have to add those options in. But if you're doing this on a terminal, it would kind of look like something like this. So you call CMake with the directory to your CMake lists, which in my case is just my root directory here, and you call in a build. You put in a build directory and you can pass in those options that we've just set. So for example, -d to set an option. We've got double pi and let's set that to on, which is a Boolean value. And also let's set the max power to something like 30, right? And I could press this just fine. In my case, it's not going to work here because I've got some extra code and stuff. So I will actually change it on my CMake settings here. So in this particular target that I'm compiling is the Unix release here. So I just have to add my options right here. So for example, I can do double pi equals on or something, equals true. And then I can also pass in my max power to something like 30, right? And of course, this has to be on a quotation mark here, but I believe this should work now. So if I basically reconfigure, I select my Unix make release, hopefully this is going to work. So you can see here on the message already, setting pi with double precision and showing the first 30 powers of pi, which just means that if I actually want my program here, so I've got my program, I expect to see 30 powers of pi as well as double precision here, and that is the tutorial for you. So we just basically looked at how you can change the behavior of your program by allowing the users to set, like, you know, compile options here through the target compile definitions, which is going to set a macro to your target, as well as combining that with an option here. And this is a very easy way to include like extra features on your compilation, or to basically change, you know, how some functions behave, or change how you implement some functions. And this is kind of done very often in very complex C++ projects. Now, I hope that you enjoyed the tutorial, and if you're not yet subscribed, please subscribe to my channel and make sure you drop a like on this video, because it just motivates me to create more and more videos like this. I've got many more CMake and C++ tutorials here, so do check it out, and I'll leave you here. Thank you guys, and bye-bye.